Hello, grade 12s. Welcome to Maths and Science 8. My name is Sewapiwe, and in this video, I am bringing you question 8 from EC June 2022 Mathematics Paper 1 exam. Question 8 is a question about the applications of calculus, specifically in the interpretation of polynomial functions. So, without any further ado, let us get straight into this one. The sketch below represents the functions f of x equals to x cubed plus bx squared plus cx plus d and g of x equals to ax plus q. So, if you look into these functions carefully, and also refer to the sketch, you can clearly see that f is a cubic polynomial and g is a linear function. The points A, B, and C are the points where the two graphs intersect, and we can clearly see where those points are on the sketch. C is a x-intercept of f, while L and M are the turning points of f. And that's also pretty much straightforward. We can indeed see that C is actually not only the x-intercept of f, but it's also the x-intercept of G. And then we can also see point L and point M, and that they are indeed the turning points of f. So, let us go straight into the first question, 8.1. Show that b equals to -5, c equals to -8, and d equals to 12. If it is given that f prime of x equals to 3x squared minus 10x minus 8. So, how are we going to do that? We can clearly see that b, c, and d are these unknowns on the equation of f. Since we are given the first derivative of f, we can take the equation of f as it is on the statement and differentiate it. So if we do that, we'll have f prime of x equals to 3x squared plus 2bx plus c, right? And obviously the derivative for d will be 0. So this will be the first derivative. And now if we compare it to the derivative that they have given us, which is 3x squared minus 10x minus 8. Firstly, we can already see that we have obtained the exact same first term. This also means that the middle term and the third terms are equal to each other respectively, meaning that we can say that 2b from the first equation equals to -10 on the second equation. And we can also say that c equals to -8, meaning that b must be equal to -5 on this side. So just like that, we have successfully shown that b is equal to -5 and c is equal to -8, which only leaves us with showing the value of d. And to prove the value of d, what we can do now is that we can take the values for b and c, since we've already proven them, and substitute them into the equation of f. So by doing that, this is the current equation of f that we will get. We'll have x cubed, and then in place of b we have -5, so that's -5x squared, and for c we have -8, so that will be -8x plus d. So d is the only unknown here. And now another thing that we need to keep in mind is that we have got at least 2 points for the graph of f, point B and point C. We can use either one of these points and substitute their coordinates into this equation of f and then solve for d. So I would preferably use the coordinates of point C for this, because it will make their calculation more simpler. So if we substitute in point C with coordinates 6 and 0, here we will have 0 equals to 6 cubed minus 5 into 6 squared minus 8 into 6 plus D. And now if you take your calculator and just sum up all of these values, you will get negative 12 here. So negative 12 plus D, which means that D is equal to 12 as expected. So just like that, we have successfully shown that B is equal to negative 5, C equals to negative 8, and D is equal to 12. So this is exactly how you can solve this problem. 8.2. Determine the coordinates of the turning points L and M of F. Well, for this one, you just need to remember that for any polynomial, if you want to determine the coordinates of the turning points, you can work out the first derivative of that polynomial and then equate it to 0, because at the turning point, the derivative of a function is 0, since the gradient is 0 at the turning point. So in this case, we already know what the first derivative is from 8.1. So that was 3x squared minus 10x minus 8. So we simply need to make this 0 and then solve for x. So to do this, we can just simply make use of the quadratic formula. So x equals to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So b is negative 10. So we also have negative 10 here, all squared. A is 3 and c is negative 8. Then we must divide this by 2 into 3. And then of course we are gonna need a calculator. Using a calculator, we can now just substitute in all the values as they are. And here we can start with plus, and then we just input in everything else as it is. So this will give us our first value, which is 4. So x equals to 4. And then we need to work out the second value. And for that, we need to change that plus to a minus. So we change this to a minus, and then we get our second value. And as you can see, it's negative 2 over 3. So now we have obtained the x values of the turning points, and we are simply left with working out their corresponding y values. But before we even get into that, we can actually check if these values make sense by using the provided sketch of these functions. So we see that one of the values of x is equal to 4, and that correspond with the x value of the turning point of m. Clearly, because m has a positive x value. However, L has a negative x value, as you can see. So that x value is clearly negative 2 over 3. So this is just something that you can always do when you have a sketch to confirm if your answers make sense. So now let us go ahead and work out the y values. And obviously for that, we can use the original equation of f, because remember, we know the values for B, C, and D. So we simply need to substitute in our X values there and find the corresponding Y values. So let's start with 4. What is the Y value of F if X is 4? Well, it will be 4 to the power of 3 minus 5, which is the value for B, remember, into 4 squared minus 8, the value of C, into 4 plus 12. So this will give us the Y value. So this will give us our corresponding Y value if X is equal to 4. And then we do the same thing for X equals to negative 2 over 3. So it's the exact same thing. Okay, now we can just use our calculators again. So starting with X is equal to 4, we have 4 cubed minus 5 into 4 squared minus 8 into 4 plus 12. And this is equal to negative 36. And then we do the exact same thing. So I'll just change the 4 to negative 2 over 3. Same thing here. And same thing here as well. And so what are we getting? We are getting 400 over 27, which is 14,81. 14,81. And again, we can just quickly verify if these Y values make sense. So the corresponding Y value for X equals to 4 is negative 36. And if you look where point M is, negative 36 perfectly makes sense. Indeed, that Y value is negative. And likewise, for point L, we have a positive Y value this time around. It's 14,81. And this also makes sense because we can see that indeed point L is above the x-axis, so it has a positive y value. So these are our coordinates of the turning points. And of course, we aren't gonna leave our working like this. We need to write the coordinates down. So your final answer here is that M has got coordinates 4 and negative 36, and L has got coordinates negative 2 over 3 and 14,81. So there you have it. So let's go to the next one. 8.3. Determine the equation of G. Very straightforward. It's an equation of a straight line. So we know that the very first thing to do is to work out the gradient. So the gradient can be found using this formula, of course. One of the reasons this is easy, it's because we already have 2 points on our straight line. So we can easily calculate the gradient. We can, for an example, use point B as x1 and y1, and then use point C as x2 and y2. So let's do the substitution. So in that case, our substitution is going to be 0 minus negative 16, all divided by 6 minus 2. So it does help, labeling your coordinates before you substitute to ensure that you don't make silly mistakes. So 0 minus 16 over 6 minus 2 will be equal to 4. So that is our gradient. But let's just note that on the general equation for G here, they have labeled the gradient with A. So we can just say here, therefore, A equals to 4, which means that at this point, the equation for G is 4x plus Q. And what we can do now is that we can, for an example, substitute in the coordinates of point C here so that we can find the value of Q, which is obviously the y-intercept. So this will be 0 equals to 4 into 6 plus Q. And 4 multiplied by 6 is, of course, 24. So we have 0 equals to 24 plus Q, which simply means that the value of Q is equal to negative 24, and therefore the equation for G of x is 4x minus 24. Okay, so this simply means that the straight line cuts the y-axis at y equal to negative 24. 8.4. If it is further given that the coordinates of A are x and negative 36, determine the length of AM. Alright, so we are being given here that the coordinates of point A are, let's label them here, they are x and negative 36. And interestingly, this has a y value of negative 36, and this also has a y value of negative 36, meaning that the line from point A to point B is a horizontal line, and we need to work out the length of such a line. So, of course, in order for us to be able to do that, we must work out this value of x, which is okay because we can see that A is the point of intersection between F and G. And we do have the full equations for both F and G. So we can use either one of them in order to work out this x value. However, it would be way easier and convenient for us to use the equation of G, since G is a linear function, as opposed to using a cubic polynomial function, which would make the calculation a little bit complex. So to do this, we will just use the equation of G that we had just worked out, which was G of x equals to 4x minus 24. So what we know here is that G of x, or the y value, is negative 36. And if that's the case, we want to work out the value of x. So we transpose negative 24 into the left-hand side. That will give us negative 12. And then on this side, we'll be left with 4x. And then we just divide by 4 on both sides of the equations. And of course, it means that negative 3 is the value of x. So right now, we have that the coordinates of A are negative 3 and negative 36. And since AM is a horizontal line, we do not even need to use the actual distance formula. We can just simply determine the length of this horizontal line from the difference between the x values of the endpoints. And how we must do it, we must subtract the smaller x value from the bigger x value so that the answer is positive. So we have 4, and we are going to subtract on it negative 3, meaning that the length of AM is 7. So this is how easy you can do a calculation like this without even using the actual distance formula. But even if you were to use the distance formula, you would be correct and still be able to get to this answer. Just that whenever you have a horizontal line or a vertical line, you can always get away with working out the distance much more easily. So this is our answer to 8.4. 8.5. For which values of x, 8.5.1 is the graph f increasing? Okay, well, firstly, you must remember that at the turning points, the function is neither increasing nor decreasing, which is exactly why sometimes we call the turning points the stationary points, because at the turning points, the gradient of a function is just 0. So the function is not increasing and it's not decreasing. However, in this case of f, we can see that on the left-hand side of point L, the function is increasing, because if you were to draw a tangent line at any point that is on the left-hand side of the turning point L, that tangent line will have a positive gradient. Or even if you were to calculate the average gradient on that side, it would also be positive. So on the left-hand side of point L, it's clear that f is increasing. However, on the right-hand side of point L, we can do the same thing, but this time around, you will notice that the function is decreasing, because any tangent that you draw on this interval, it has a negative gradient. However, on the right hand side of point M here, you see that once again that the graph is increasing. So this is a very straightforward concept. When a function is increasing, it means that as the x values increase, the y values also increase. Therefore, the average gradient is positive. But if a function is decreasing, it means that as the values of x increase, the y values decrease. So to answer 8.5.1, we can simply say that the graph of f is increasing if the values of x are less than -2/3. As you can see, for all those values of x that are less than -2/3, because -2/3 is right here, it's that x value at the turning point of L. So if your values of x are less than -2/3, we can clearly see that this function is increasing. But on the other end, if the values of x are greater than 4, you can also see that our function f is also again increasing. So, or x must be greater than 4. So this is our solution to 8.5.1. These are those values of x where the graph of f is increasing. Just remember that alternatively, this can also be written using the set notation as x is an element, negative infinity, -2/3, union 4 into positive infinity. All right. Moving on now to 8.5.2, which is asking us to determine whether for which values of x is the graph f concave down. Where is this graph concave downwards? This is also easier to determine from the sketch. We can see that around the turning point L, our graph is actually concave downwards, you see. However, around the turning point M, it is concave upwards. So we are interested on the values of x that are around point L. However, in between point L and point M, there will be a point whereby the concavity changes from downwards to upwards. And that is the point which is usually referred to as a point of inflection. And that's exactly what we need to work out here in order for us to be able to accurately answer this question. And for that, you must remember that in order to determine the point of inflection, we need to get the second derivative of a function and then equate it to 0. Because at the point of inflection, it turns out that the second derivative for a function is 0. So since we already know the first derivative of our function of f, so we know that it is 3x squared minus 10x minus 8. So we need to differentiate it in order to get the second derivative, which will be 6x minus 10. And then if we make this equal to 0, what is the value of x we get? So let's maybe transpose 6x into the left-hand side to get negative 6x equals to 10. And then let's divide by 6 on both sides. So we get that x is 10 over 6, which we can simplify to 5 over 3. And as a decimal, let's see what this would be. So I'll just input 5 over 3 into my calculator. So that's 1.67. So this point of inflection is a point which is around here. We can say that it is around there. That is where 5 over 3 would be if we just estimate in this case, meaning that our function is concave down all the way up until we get into that point with an x value of 5 over 3. So after 5 over 3, the concavity of our graph changes from downwards to upwards. Therefore, to answer this question, it means that the values of x where the graph of f is concave down, it's all those values that are less than 5 over 3. So as long as x is less than 5 over 3, the function of f will be concave downwards. Okay, so this is simply how you can work through such questions, guys. And so this is the end of this video. If you have found this helpful, please don't forget to like this video. And if you have got any questions or you would like to give me some feedback, please feel free to leave your comment on this video. And if you haven't done so already, please make sure that you subscribe and share this video with your classmates so that they can also get this information and hopefully learn something from it. Otherwise, I hope to see you on other videos. As always, wishing you all the best.